Hello student, today I am going to start a very interesting topic, physical properties of 13 group are p block element are boron family. The all element classify in a 4 block, S block, p block element, T block and F block element. In p block element, group is 13 to 18. The outer electrons enter in a p subcell. The general electronic configuration is NS2 NP126. In p block element, first is a 13 group are boron family. The member is boron, aluminium, gallium, indium and thallium. Boron occurs in our nature in the form of orthoboric acid H3VO3 and borax Na2V4O7 into 10H2O. The occurrence of boron in nature according to mass 0.001% only. The existence of the aluminium, third most abundant element in our nature. The existence of alumina in the form of alumina hydrated is called bauxite, cryolite Na3Al F6 and corundum Al2O3. Gallium, indium and thallium occurrence is a trace amount. The gallium occurs in zinc, copper, germanium, sulfide ores. And also 1% almost gallium occurs in germanite. Germanite is a mineral of zinc, copper, germanium and arsenic. It means gallium, indium and thallium occurrence is a trace amount. Maximum occurrence in our nature is aluminium in the form of bauxite, cryolite and corundum. Boron occurrence is only 0.0001%. Boron is have two type isotope V10 and V11. V10 occurrence only 19% and V11 occurrence is 81%. In p block family, the first group is the 13 group. In 13 group, boron, aluminium, gallium, indium and thallium. Boron is a non-metallic nature element and aluminium metallic nature element. Boron exists in 4 allotropes. One is amorphous, and the amorphous appearance brown color and more reactive. And second is a crystalline. Crystalline appearance in a black color. The building block of boron is a isohedral V12. It have the 20 face. It is the building block of all type allotrope of boron, amorphous or crystalline. Electronic configuration of 13 group are boron family are boron atomic number 5. Electronic configuration is 1s2, 2s2 and last electron enter in a 2p subcell. Aluminium atomic number 13, 1s2, 2s2, 2p6, 3s2 and 3p1. Last electrons enter in a 3p subcell. Gallium 31 atomic number 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and after 4s 3d10, 4p1. It means 3d10 electron, 3d subcell contain 10 electrons. It not protect 4s electron from the attractions of the nucleus. इसका मीन सिंपल सा बेटा ये है कि गैलियम के न्यूक्लियस में 31 प्रोटॉन्स होती हैं. 31 प्रोटॉन्स स्ट्रांगली अट्रैक्ट करेंगे 1s को, उसका 2s को, फिर 2p को, 3s को, 3p को. आप इसको ऐसे कह सकते हैं तो 1s electrons protect of 2s electron, 1s and 2s protect of 2p6 electron, and 1s 2s 2p6 protect of 3s electron. It means 3d subcell contain 10 electrons, diffuse shape and less penetration effect than 3d10 electrons not protect of 4s2 electron from the attractions of gallium nucleus. Next is the indium, atomic number 49, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2 and 4d10, 5p1. It means 4d10 electrons not protect 5s electrons from the attractions of the nucleus of indium, and indium content is a 49 proton. Next is the thallium 81, atomic number 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10 and 6p1. It means 24 electrons in a 4f subcell and also 5d subcell. It means 4f 14 electrons, 5d 10 electrons not protect of 6s electron from the attractions of the nucleus in thallium atom. Then 6s 2 electrons strongly attracted by the nucleus of the thallium which contain is a 81 protons. Then 6s electrons generally not participate in the bonding process. Again, in case of the thallium, thallium content is a 81 proton in a nucleus. The outer shell of thallium is a 6. 6s2, 4f14, 5d10. 4f and 5d is a weak shape subcell, diffuse shape. Then 4f, 5d penetration effect is a very little. Then 6s is small subcell and it have more penetration effect than 6s close to nucleus. Then 81 proton of the nucleus strongly attract of the 6s electron. Then 6s electrons not participate in the presentation of the oxidation number or formation of bond. Then 2 electrons in a 6s subcell, it behave as a inert electron pair. Then only 6p1 electrons participate in the bonding process or oxidation number. Then thallium generally have monovalent cations, but aluminium always form aluminium trivalent ions. That is the effect of inert electron pair. What is the effect? The aluminium generally form is a aluminium trivalent ions and it is a stable. But in case of the thallium, thallium is generally form monovalent cations. Why? Because thallus ion more stable compared to thallic ions because 6s electrons strongly attracted by the nucleus of the thallium. It not participate in an oxidation number or bonding process. Then this electron is called inert electron pair. Next is the oxidation number. Oxidation number, boron atomic number is 5. 2 electrons in a K cell and 2s2. Next is a 2p1. This is the ground state where the appearance is only 1 electrons in a unpaired in a p subcell. But boron is a trivalent or form plus 3 oxidation number compound because the 2s electrons jump from 2s2 to p. Then oxidation number of boron or aluminum is 3. But in case of the thallium, 6s electrons strongly attracted by the nucleus of the thallium. Again, the effective charge of nucleus, 81 proton contained in the nucleus of the thallium. 4f and 5d is a large shape subcell. It not protect from the attractions of the nucleus of thallium of 6s electrons. Then 6s electrons strongly attracted by the nucleus of thallium. It not participate in the bonding process or exhibition of the oxidation number. Then thallium oxidation number more stable, only +1 in place of +3. Then thallus ion more stable compared to thallic ions. What is the difference between thallus ion and thallic ions? The thallus means thallium is a monovalent. Thallic means thallium is a trivalent. Inert pair effect. Boron outer cell is a 2s2 2p1. Aluminium outer cell only है ना, 3s2 3p1. Gallium 4s2 3d10 4p1. It means the 10 electron of the 3d subcell not protect of the 4s electron from the attractions of the nucleus of gallium. In case of the gallium, boron, aluminium, gallium. Next is the indium ion. Outer cell is a 5s2 4d10 and 5p1. It means the 10 electrons of the 4d not protect of the 5s electron from the attractions of nucleus in case of indium. Next is the thallium. 6s2 4f14 5d10 and 6p1. 24 electron in 4f and 5d subcell. It not protect of 6s electron from the attractions of the nucleus of the thallium. Then thallium nucleus strongly attract of these 2 electron. Then it not participate in the presentation of oxidation number or formation of compound. Then this electron pair is called inert electron pair. But what is the effect produced? The effect here, the thallium is form stable thallus ion and aluminium always form aluminium trivalent ions, because in case of the thallium 6s electron strongly attract by the nucleus of thallium. Then 6s electron not participate in the bonding process or exhibition of the oxidation number. Then this electrons pair is called inert electron pair. And effect here, thallium show only +1 oxidation number in place of +3 oxidation number, and this effect is called inert pair effect. Gallium and indium is also form +3 and +1 oxidation number compound. But gallium, indium +1 oxidation number compound is so disproportional reactions in water. In case of the chemical behavior of the 13th block, we are clearly explained of the disproportional reactions of the gallium and indium. Next is the ionization enthalpy. The ionization enthalpy play a very important role of the formation of the compound. The compound is a covalent or ionic. In case of the boron is a small size element in their family. The outer cell is a first is a 1s2, second is a 2s2, next is a 2p1. And the S is a small size. Atomic number 5, 2 electrons in a 1s2 and 3 electrons 2s2 and 2p1. The effective nuclear charge of boron is very strong. Then the required energy for the ejections of the electron, 3 electrons from the boron, is very large amount. The lattice enthalpy and hydration enthalpy not provide the sufficient energy for the ejection of the 3 electrons from the outer shell of the boron. Then boron generally form covalent nature compound because the boron first ionization enthalpy is 801 kilojoule per mole. Boron to boron monovalent ions. Second ionization enthalpy of boron is 2427 kilojoule per mole. And third ionization enthalpy of boron is 3659 kilojoule per mole. It means sum of these three ionization enthalpies is a very large amount. This large amount not compensated by the lattice enthalpy or hydration enthalpy, then boron only form is a covalent compound. Next is in case of the ionization enthalpy, one is a aluminium, second is a magnesium. Aluminium atomic number is 13, 1s2, 2s2, 2p6, 3s2 and 3p1. But in case of the magnesium, magnesium belongs to second group alkaline earth metal. The atomic number is 12, 1s2, 2s2, 2p6, 3s2. What is the difference between the electronic configuration of the aluminium magnesium? The basic difference in aluminium magnesium electronic configuration is aluminium outer shell third subshell 3p content is a 1 electron. It is unstable in nature. But in case of the magnesium, atomic number is 12. The only 2 electrons in a 3s2, it is stable. Then the first ionization enthalpy of aluminium is कौन ज्यादा होगी भाई? एल्युमिनियम की मैग्नीशियम की? Definitely the first ionization enthalpy of second group are alkaline earth metal is more than 213 group, because in case of the magnesium, the 1 electrons ejected from the stable 3s configuration, the required energy is 737 kilojoule per mole. But in case of the aluminium, the first electron ejected from the 3p1, the required energy is little amount, 577 kilojoule per mole. It means the first ionization enthalpy of aluminium less than 2 magnesium, because the 1 electrons, first electrons ejected from the less stable 3p subshell. What? When the 1 electrons ejected from the aluminium, aluminium change into aluminium to aluminium monovalent ions. When 1 electrons ejected from the aluminium, aluminium change into aluminium monovalent ions. When aluminium change into aluminium monovalent ions, the electronic configuration of outer shell is 3s2. Then if electrons ejected from the aluminium monovalent 2 for aluminium divalent, the required energy, second ionization enthalpy of aluminium is 1816 kilojoule per mole. It more than 2 required from the 1 electron ejection from the magnesium, because in case of the magnesium, when the electrons ejected from the magnesium one electron, magnesium change into magnesium monovalent ions and configuration is 3s1. पहले 3s2 था ना भाई, 3s2 3s1. The required energy only 1450 kilojoule per mole and magnesium change into magnesium divalent ions. It means the second ionization enthalpy of magnesium more than 2. First ionization enthalpy of magnesium, what compare of second ionization enthalpy of magnesium and aluminum. Aluminium second ionization enthalpy is a 1816, but magnesium second ionization enthalpy is a 1450. Then second ionization enthalpy of 13 group always more than 2 alkaline earth metal. Third ionization enthalpy more than 2 other. फिर again is in case of the aluminium, the outer electronic configuration is 3s2 3p1. The amount of the energy supplied, then aluminium change into aluminium monovalent ions 3s2. Again energy supply, it change into 3s1 aluminium monovalent to aluminium divalent. In case of the initial, the 13 proton of aluminium attract of 3 electron of the outer shell. What aluminium change into aluminium monovalent ions? What is the amount of the energy required for the ejection of the 1 electron from the aluminium? 577 kilojoule per mole. And aluminium change into aluminium monovalent ions. The electronic configuration of outer shell is the 3s2. When electrons ejected from the aluminium monovalent ions, the required energy 1816 kilojoule per mole. If it means 1816 kilojoule per mole energy supply of the aluminium monovalent, then aluminium ejected 1 electron change aluminium monovalent to aluminium divalent. In case of the divalent, only 13 proton attract only 1 electrons of the outer shell. The required energy is called third ionization enthalpy is large value compared to first and second. This value is a 2744 kilojoule per mole. It means third ionization enthalpy more than two others. Electronegativity. It is a very interesting topic. Electronegativity. Boron, aluminium, gallium, indium and thallium. What is the electronegativity? The two is the properties. One is the electron gain enthalpy. The electron gain enthalpy is the properties of the isolated gaseous atom. What electronegativity measure within a molecules. Boron is a small size. Then electronegativity of boron more than to aluminium. We move from up to bottom. What is the concept? Generally, we move up to bottom in a group. The atomic size is increase. When the atomic size increase, then distance from the nucleus to outer shell is also increase. Then electronegativity is definitely is a decrease. The electronegativity decrease from boron to aluminium after that suddenly is increase. The highest electronegativity of boron, and boron forms generally covalent nature compound. Electropositive and metallic character form trivalent ions. इसके पहले हम लोग देख चुके हैं बोरॉन आउटर इलेक्ट्रॉनिक कन्फिगरेशन एटॉमिक नंबर इज 5 1s2 2s2 2p1 and boron is a small size. The amount of the energy required for the ejection of the electron, first electron 801, for second electron 2427 and for third electron 3659 kilojoule per mole. It means the required energy for the ejections of the 3 electrons from the boron, sum of these 3 ionization energy, first, second and third ionization enthalpy is a very large value. Then boron is formed generally covalent compound because lattice enthalpy and hydration enthalpy of boron not provide the sufficient value for the ejection of the electron from the respected outer shell. That boron nature is a non-metallic nature. But aluminium large size compared to boron, then aluminium eject 3 electrons from their respected outer shell and aluminium change into aluminium trivalent. The general concept is up to bottom in a group atomic size is increase. Then ionization enthalpy is decrease. That is the general concept in a classification of element. We move up to bottom in a group, the atomic size is increase, then distance from the nucleus to outer cell is increase, then ionization enthalpy is decrease, then electropositive or metallic nature is increase. And thank you very much.